For problem 4 in the Unit 7 part of the review, we want to find the area of each quadrilateral below. And we're going to round our answer to the nearest tenth if necessary. So if we take a look at A, we have a rectangle. So again, the formula we are going to use for all parallelograms, four-sided figures, or parallelograms, is base times height. And when we have a rectangle, the sides are just the base and your height. So we can make the bottom part our B and the side part our H. Well, problem is we don't know our base. They didn't give that to us. They gave us our height. We know our height is 5.9. We just don't know what our base is. But there's a way we can find it. I notice here they drew in this diagonal for us and they told us our diagonal was 17. I know this is a rectangle, so I know all four angles are right angles. So think, how can I find the missing side of a right triangle? We can use the Pythagorean theorem. When you're given two sides of a right triangle and you're trying to find the third, you can use the Pythagorean theorem to find it. C always has to be your hypotenuse, the side across from the 90-degree angle. Then it doesn't matter, I'll make my height my A and my base my B, so they're the same letter. So I'm just going to plug that in the Pythagorean theorem. A squared plus B squared equals C squared. So my A is 5.9, my B is just going to stay B squared, and my C is 17. So then figure out first what is 5.9 squared. So I'm plug that into Desmos. I'm going to do 5.9 squared, and I get 34.81. So this becomes 34.81 plus B squared equals 17 squared, 289. We need to get B by itself, so I'm going to subtract the 34.81 on both sides. So B squared equals, I'm going to do 289 minus 34.81, and that gives me 254.19. To get B by itself, I'm going to square root. And I know it seems a little silly. Take the square root of it in Desmos first and see if we get a normal, like a fairly decent number. And we don't. We get a really messy decimal. So I'm going to leave it like this radical to get the most accurate answer that I possibly can. It seems strange, I know, but just leave it like that radical. So we got that our base, so when we go to find the area, my base is this strange radical, times our height is 5.9. So that's what we're going to plug into your calculator or into Desmos. We're going to do radical 254.19, which I already typed in there. Make sure you arrow up, times 5.9. When we round that to the nearest tenth, that's one decimal place, so we go one more. That 6 will bump a 0 up to a 1. So we're going to write it as 94.1. And we're going to say inches squared. Done. If we take a look at B, we have a parallelogram. So again, to find the area, we are just going to use this formula, base times height. Well, my base, I like to think is the nice flat bottom part. That's my base. Our height is either the line that's on the inside or outside that is perpendicular to your base. Okay, that's our height. Again, the problem is we don't know what it is. They're withholding that from us. So we need to find it. Well, I know my height is perpendicular to my base, and I notice that my height is part of that blue triangle right there. And I know that that triangle is a right triangle. So there's two ways to find the missing side of a right triangle, using Pythagorean theorem or trig. For B, we have to use trig because we only know one side of the right triangle. In order to use the Pythagorean theorem, you have to know both, at least two sides. We only know one. So that means we have to use trig. That means we have to use SOHCAHTOA. And if it's helpful, draw the triangle outside. I know my height's the up and down part. We don't know what the bottom part is. We know the slanted part is 6, and this bottom angle is 60. So I'm going to start with my angle they gave us, the 60-degree angle, and label. We go across, that's our opposite. We go to our 90, go across, that's our hypotenuse. Side left over is our adjacent. Well, our opposite has our variable, that's what we're trying to find. Our hypotenuse has our number, so that means we're going to use sine because that is involving the opposite and the hypotenuse. So we are going to say sine of our angle equals the opposite over the hypotenuse, h over 6. Our variable is up high, so we are going to multiply. We're going to multiply both sides by 6. And this is what you're plugging into your calculator. So you're going to plug 6 times the sine of 60. It's very, very, very important. You have to make sure your calculator is in degrees. If you are using Desmos, and you're not using the Ohio one, you're just using the generic one, you just hit this little tool up there, and then just tap degrees. Now you're in degrees. So we're going to do 6 times the sine of 60. And around that to the nearest tenth, I'm going to say 5.2. When we round to the nearest tenth, it's 5.2. When we use trig, it's okay to round. If we have a radical, keep it as a radical, but we're going to round here to 5.2. So that's our height. So now that we know what our height is, and we know our base is 10, to get the area, I'm just going to do 10 times 5.2. And when we do 10 times 5.2, it gives us 52. That's easy math. So our area is equal to 52 centimeters squared. Sorry, it's a little scrunched over here. I'll write it in blue, maybe to let it stand out a little bit more. But our area is 52 centimeters squared. And there you go. There's number 4. I think that's the last one in this review as well.